Okay, we're going to look at applications involving exponential equations. Okay, population growth. Right, the exponential growth rate. Okay, here's the equation. Right, we have an initial population. Okay, and then in some future time, the population grows exponentially. And we've got this new population here. E is the base, E is involved in the equation. K is the growth rate, and again, T is the amount of years in the future. Okay, so let's have a look at something down here. Oh, by the way, here's your classic exponential graph. All right, you've seen it before. So just be aware, remember, K is the exponential growth rate. K is greater than 0. If K was less than 0, things would be decaying, things would be getting less. Of course, it's population, things are getting more. Okay, right, let's look at some of these questions. We've got Ghana. Okay, in 2013, the population was 25.2 million. So that's where I would put 25.2 million at P0. In fact, I'm going to write that. Okay, 25.2. Okay. Okay, E. The growth rate is 2.19%. We write that as a decimal. So 0.0219. And then T, the amount of years. It just wants the function, okay? And there it is. Let's have a look. Right there, okay? Okay, what else do we have? Estimate the population in 2018. Well, that's in 5 years' time. All we're saying is put 5 where T is and put it into your calculator. Okay, there we go. And apparently it comes out to be that. Be careful when you put it in your calculator. Oh, what else do we have? Right, after how long will the population be double what it was in 2013? Okay, now if I take this, all right, double means the population I'm looking for is 50.4 because that's double 25.2, okay? So this is the equation I'm going to be using. Let's have a look. Okay, here it is. Okay, again, doubling time. So that's what they've done right there. Okay, now if you think about it, now to solve this, all right, I need to get to this T. So I need to get rid of that 25.2, and that means dividing both sides by 25.2. Please don't subtract like a lot of students do. Divide both sides by 25.2 and you'll get 2. And the reason why it's 2 is because it's the doubling time. All right? Okay, so we've got this equation here. Now once we get to that, we are using our log properties. Okay, how do I find T? Log both sides. Okay, so let's have a look. We log both sides. Okay, there it is. We log both sides. Now remember, the log to base E, if you think of that as an E, of E to the point 0.0219t is just 0.0219t. Go back and look at your log rules. Okay, there. Of course, this is still log 2. Divide both sides by 0.0219. There we go. And t is 31.7. Okay, so about 32 years later, all right, so if you actually had to write a year, that would be 2000, and what's that, 45? If it's about 32 years later, okay, so don't forget to finish it off. 32 years beyond 2013, 2045, okay? Right, another question. At this growth rate, when will the population be 40 million? Well, it's very similar to you doing this, all right? Here we go. 40 million on this side. Instead of double, which was 50.4, we're just saying how long does it take to reach 40 million. So it's just the same. You're not doing anything different. We've just put 40 there instead. Again, you divide by 25.2. Now, I'm actually going to do this. I don't like the way they've done this. I like to get rid of that 25.2 right now. So I'm going to actually get the calculator going. Okay? So let's have a look. So we have 40 divided by 25.2 is that. Okay, and when we're going to natural log that. Okay, so here we go. Again, remember we log both sides. So I should write here. I would write 1.5. Was it about 1.59 approximately? Where's the calculator? 1.587. Okay, instead of this here, right? So the log of this, or 1.59, natural log, is 0.462. Again, so I would write this as 0.462. Now remember, they're divided by the number next to the letter. Here it is. You put that in your calculator. Let's have a look. Divide by 0.0219. divided by 0.0219 equals, what's that, 21.1. Okay, about 20, there you go, 21 years. So 21 years later, or in other words, 2000, what's that, and 34? Okay, so that's the year it will reach 40 million. Okay.